Today on the bench we have a 750 APower ATX PSU. This one had a pretty unusual problem, well, maybe not unusual, but when it connected to power it would give you 12 volts, 5 volts, 3.3, just PG was low. So this is actually a little hard to test with just a multimeter. You need a device like this or build your own. And the PG should go high after 100 milliseconds, but no later than 500 milliseconds after the motherboard requests the PSU to turn on. If the PG stays low or goes high after 500 milliseconds, the motherboard won't turn on. So this PSU technically was delivering proper voltages, but no PG, so the motherboard wouldn't turn on. And the repair was pretty simple. Let's see what I did. Alrighty, now let's get this one. Number 5. So far only 2 I've managed to fix, or at least for now. I haven't given up on the other ones yet. Oh my god, that is a great packaging. And I get a little note. Okay, ship to blah blah blah. Returns not accepted. Obviously, because it's not working. Look at this packaging. Excellent. And it came with a power cable. Imagine that. Okay. Very light for 750. Very light. Why is it so light? Well, it says 750 on the sticker, that's for sure. It has been opened, yeah. It has been opened, which is fine. Actually, let's use this one. This one's for power supplies. And what one is this one? Okay. Or maybe it wasn't opened. There is a sticker here on this screw, but it doesn't look very legitimate. Maybe it's just a QC past, so it's not the actual measurement to prevent you from opening. Oh, and look at this. No, but this doesn't hold it. Yeah. Oh, it did. Okay, because these are the computer screws. They were just in the way. Okay. Oh, nasty. It's a very old design, and I don't know. I wouldn't say this is 750. Looks more like 6, maybe 650. But I might be wrong. Okay, let's see the old school clip. Yeah, this doesn't feel like 750. Doesn't weigh like 750. Okay, let's just grab the board. This is the old design, alright. Yeah, that's only gonna be caps on this one. This one should be easily fixable. It doesn't feel like this has been unscrewed any time, you know, and there's corrosion. Okay, signs of corrosion. Come on, get out. Get out there. Okay, and this guy, and this guy, and nice. Okay, I don't have to desolder anything. I have perfect access. Yeah, this definitely is the old design. That's why it doesn't feel like 750, because I don't remember 750 watts to even be a thing back when this design was popular. Actually, let's do the quick short finding on the input. Rectifier, good. Input, good. What was that? Okay, good. No short. Where is the fuse? Fuse is good. Shorts on the transistors, none. None. What is this? Maybe diodes. Okay, no shorts here. Output diode. This should be shorted, just not here. Good. Oh. 46 ohms. That's acceptable. Although this is on the output of the diode, right? No, that's the main transistor here. This is the primary. No, this is secondary side. Okay, this is the primary side. Yeah. Okay. So this must be a diode. A huge one. Yeah. I don't think that's a short though, because the output on the what do you call it, 12 volts or 5 volts could be very low. This is open line here. Let's see this guy again. 45 ohms. So that's good. That's good. That's not a dead short, so I'll just ignore it for now. And let's get to the probable cause. This guy. Open line. This one's good. And open line. Let's mark them because some are good, some are not. So this guy, no bueno. Okay, so this one was replaced because it's a different one. That's why this one's good. So this must have been repaired before, and this one seems to have been replaced because it's not sitting right. It's crooked, so that could be that could be the culprit, the main culprit. Let's test this one. That's too bad because this one has poor access. Okay. How about this little guy? Oh, there's something missing here. Looks like there's a capacitor missing. No, this is. Oh, looks like it was fan 1 and fan. I don't know. Or maybe that's a. Whatever. Okay, so this guy. Where's this guy? Is it possible that it's this? Yeah, it's gotta be this. This guy's not sitting right. This one's gotta go too. Here. Okay, thank God this one's good. Probably all the others are either good or not crucial. Alright, let's turn it on and see if we have standby. Well, let's do it through the light bulb. So I'm not gonna be testing power. Quick diagnosis. Please stand by. This is PS on, which also should have 5 volts, and PG 5-volt standby. Which one is it? Maybe I'll just test it on here. Yeah, I'll just test it here. And this thing, set like this. Cable here. Is there an on switch? There is. Okay. Oops. Right. Now, turn it on. No flash from the light bulb. That might mean that smoothing caps are not doing their job. And now let's check the standby voltage. They said no purple. Let's catch the ground somewhere. Maybe here. Yes, and we got 519 on standby. So standby is working. If this doesn't turn on, that means those cups should be. Well, that's a 12.4 and 12.3 on V1. V2 not present, good, it's not connected. Oh, that's not the one. Oh, it doesn't have V2, okay. So I'm not gonna connect V2 here. Have this, but that's also okay. 5 and 12. Well, it's definitely, even though it's turning on now, it's not going to work under load because of those caps. I've seen enough of these that it's definitely. I'm not sure about that PG. Why is the PG flashing? Under caps here. Okay, let's get the caps replaced and see what it's gonna do. Alrighty, so 3 of those caps have been replaced, but this time I did it just like this, just to check it. On the off chance that it's not gonna work, although on these kind of devices with this control chip, it's usually the output capacitance is the cause of issues. And I checked the PG. Indeed, it was 0. It was low. So the tester said 0 milliseconds. So I thought it just came up too early, too quickly. But no, it just never went high. So that was the issue. Now let's see if we're gonna have PG after replacing those caps. And the cable, yeah, and we have 260 milliseconds. So that is correct. Well, correct. It's got to be more than 100 and less than 500. 3.4 beautiful, 12.3 beautiful,
5.2, beautiful. No V2 because I don't have a cable. Actually, I might have a cable somewhere. I'll look for it. And but it should be the same. Alrighty. So now the next step is to actually resolder those caps properly, but this is the 3300 16 volt that I removed, and I only have one like this, much wider. I'm not sure I'm gonna be able to actually fit it there, but I don't have the 3300 in this package, so that's kind of sucks. But let us see. Let's replace those and put some load on it and see if it's actually 750 watts. Alrighty, now that it's all put together, let's test the load on it. So I'll use both the meter over here, and I'm testing voltage on the load directly. So this should give me about 11.3, and actually on this one I don't want to see anything lower than 11.3 because it's supposed to be 750, so the should be around, yeah, let's just see. I'm not sure what we'll see. 12.31 and 12.4 on the PSU. On the other cable, 5.2 is also loaded. Oh, okay. It would work a lot better if I actually connected the load. Okay, good thing that's why I have the light bulbs on it, so I see that it actually did turn on. So now again, 11.29. Yeah, that's within the range. And we got 12.0 on the PSU, 5.2 and 12.0 and 5.2. That's good because 5 volts is also loaded. Actually, it's heating up very quickly. Okay, and the cables as well. Oh, cables are getting hot, but it survives the load nicely. The voltage is over 12, so PG is still high. So this is it. The PSU is ready to be sold again, ready to be used again. Alrighty, and fault. Oh, actually, after I started replacing the caps, I noticed that I missed this one. This one was on the 5-volt rail. I marked it to be replaced, but I only replaced those 3, which already helped with PG being high. But now this is basically the whole repair of this device, and it's going to my collection of trash. There you go. Alrighty, thank you very much for watching, and I'll see you guys in the next one.